Welcome all of you. Today class actually we are going to see about sampled data control system. What is sampled data control system? Sampled data control system, which is nothing but either the signal or the information in a system is in the form of discrete pulses. Then the system is called discrete data system. What does it mean, signal? Generally, signal, which is nothing but, which consists of the general form is A sin omega t. That means this A is the representation of amplitude, frequency, and then phase information. This is what we used to call it as a signal. And this particular signal or a system, it should be in the form of discrete pulses. So discrete pulses in the sense, it's like we are having two signals generally. One is analog. This is what your analog signal. Discrete signal in the sense, if the signal which consists of, it is like in the form of pulses. So this is what discrete. So generally the analog signal, it's going to convert as a digital. In between the analog and the digital, there are two processes taking place. The first one is called it sampling, then another process which is called as an hold. So we can't able to get analog signal as it like a binary form. That is why we have to get a knowledge about sampling as well as hold. So what is sampled data control system? So generally the signals are in the nature of discrete pulses. Then the system is called discrete data system. So the discrete data system, which is also called it as an sampled data system. So when the sampled data control system, when the control system is going to become a sampled control system. So if a particular system which consists of a digital computer or microprocessor or microcomputer which employed in the control loop. What does it mean? You all know how the control loop will be. You will have an error detector, then you have a controller, then you have a plant, then feedback that will be connected to the error detector. So here you will have an input and the output, error detector, controller, then you have a plant, right? But when instead of using this controller, if I am using any digital computer or if it is replaced with microprocessor, then it is called it as a digital computer. So whenever this particular thing is going to be digital computer, then the whole system is become sample data control system. The next one is whatever the components in the sense your error detector, input, output, plant, controller, whatever the component you are going to use it in the loop, that component is used as a time sharing process, time sharing basis. Then your system is become sample data control system. Then the control signals are transmitted by a pulse modulation. So pulse modulation means it will be in the nature of this particular signal. Then either your input or your output is the system is in the nature of digital, that means your zeros or 1, or which will be in the nature of discrete, then your system is going to become as a sampled data control system. Then there are two controllers generally, one is analog controller, then digital controller. So what is the comparison of this analog and digital? Why the people are going analog versus digital? So where you are using analog controller, whatever the element you are going to use it, they are analog elements. And the output is it the nature of continuous function of time. Then it become a complex because there are so many elements we are using. So automatically the cost is also high. And moreover, once the fabrication is over, you can't able to alter the component. That is the reason why we used to call analog controller is a complex controller. Then we can see what are the advantages of digital controller. So digital controller means instead of using analog, we are replacing with the digital, that is your microprocessor or your microcomputer. So what are the advantages of digital controller? It is very simpler. It is programmable one, versatile and fast acting as well as less cost. And moreover, the system we are going to use it as a MUPI are the nature of programmable. Here I have given the block diagram of sampled data control system. So the block diagram of sampled data control system, which consists of input, that is your U of t is in control signal, the output of your error detector. The input of error detector, we have an R of t. R of t we used to call it as in reference signal. So R of t is in reference signal. Then you have an feedback signal. So whenever this error detector, which is going to give the difference of your reference as well as your error signal, the signal output we have taken here as an U of t. The U of t is an input of your sampler and ADC. What is ADC? ADC, which is nothing but analog to digital converter. So analog to digital computer, the sampler, which is nothing but it act like a switch circuit. That is what sampler. The sampler which act like in switches. So the output of the sampler we are going to have is in the form of digital. The input of your sampler is an analog signal. So whenever you are going for control design, the input as well as the output both should be in the nature of analog. And we have taken as an input signal is physical signal, and the physical signal which will be in the nature of any signal, either it can be a sound, vibration, pressure, temperature. These are the signals are an example of your physical signal. After sampler, your signal is going to be like a digital error, and the signal we have represented f of kt. So after that, the signal as an input of your digital computer, and the digital computer, once the process is getting over, the signal is g of k into t. The capital T is nothing but sampling time. So the output of digital computer is a digital control signal. After digital control signal, I already told you, whenever you are going for the control system, the output should be an analog. So how I can convert this particular digital signal into an analog signal? So I am in need of some conversion part. That is the reason we are going DAC. So your digital signal is getting converted in terms of analog. So using DAC, and the DAC we have a function called hold. So here this hold process, actually how this perform your signal, the input is in the nature of analog. Then this analog signal is given into a sampler. So what the sampling will do, the same analog signal here it will be getting sampled. So that is what I told you, that capital T is in sampling time. So once the signal is getting sampled, so if it is getting sampled, then it will be like this. So it will be in the form of discrete. So the output of a particular signal, it will look like this. Okay. So this is what the sampling instant. After sampler, my discrete pulse signal. Then the signal which will be given as an input of the hold. So the hold, your output is going to become, there are two things. So this particular, you will have this wherever the sampling instant is going to happen. So that will be taken care of hold. So after holding, you will get a signal which will be in the nature of like this. So this particular thing, they used to call it as a step size. So when you look at this particular signal, there is an upper, lower, upper and lower. So wherever the high thing, this is actually logic 1. So the lower one, which is logic 0. So automatically your signal is the representation of zeros and ones. So you are getting a digital. Okay. So after that, this particular signal will be getting into converted into analog by the use of your DAC part. So finally the output, after the plant, I am going to get output in continuous nature. So whatever the process inside the sampler, ADC, digital computer, DAC, those three blocks are called digital controller. So this is what the general block diagram of sampled data control system. The next one is about the advantages of digital controller and advantages of sampled data control system. Advantages of digital controller, which is nothing but it provides large and complex computation with any design system. Whatever the system you are going to configure, if it is in complex nature, that will be getting sort out. That means the error will be getting minimized and you will get an high accurate output. That is very, very important. Then the whole process which will be in high speed. Then we can easily programmed and versatile one and better resolution. They are the advantages of digital controller. The next one is sample data control system advantages. They are highly accurate, fast. Then it provide better resolution and they are less affected by noise. The error will be getting reduced and they are providing a non-linear nature that will be minimized. So you will get a noisy free signal and also it provide high sensitivity. So these are the advantages of sample and the digital controller. What is sampling process? So I already told you, you are sampling which consists like a switch. So your analog input signal, the continuous signal is f of t. After sample you will have the output f of kt. So here using this particular switch, this will be converted in terms of discrete time of signal. So the signal is getting changed k and t, which is nothing but sampling time, and this is also called it as a sampling period. T is also called sampling rate. You all know that f, which is nothing but 1 by t. Okay, and the sampling process, you have an continuous signal. That continuous signal, after sample you will get a sampling instant. After holding you will get a signal like this. Then you will get a step size signal. This will be the representation of binary. So finally you are getting digital signals. So in digital signal there are two processes going to happen before converting in terms of binary, that is quantization and coding. So whenever the discrete time continuous signal get converted discrete time discrete valued signal, that is called the quantization. Discrete time but continuous into discrete time discrete valued signal, that is what quantization. Then coding means this signal is get convert zeros as well as ones. So while you are concentrating sample and hold unit, which consists of three operations, that is sampling, quantization and coding. So simply speaking, we have a sample and hold, but it consists of three processes. The process are called as in sampling, quantization and coding. After these three processes only, we are getting a signal in terms of analog to digital. So simply we can call the analog to digital, but it is not so. In between the analog and the continuous, there are three processes happening: sampling, quantization as well as coding. Okay, and sampling, there are three different types of samplings we have. The first one is called periodic sampling, multiple order sampling, then multiple rate sampling, multiple random sampling. What does it mean? Periodic sampling in the sense, whenever the samples are going to take per second, samples per second we can call easily. That is, whatever the signals you are going to get output of the sampled, that is what actually called periodic sampling. So periodic sampling means, which is nothing but after a sampling interval, whatever the output you are going to get, the samples per second or sampling frequency. This type of sampling, which is called periodic sampling, the samples are obtained uniformly at interval. So whatever the samples, that should be in uniform nature. Whatever the interval I am going to take, it should be uniform. That is what this is called periodic sampling. The next one, multiple order. Multiple order sampling means a particular sampling pattern is repeated periodically. Whatever the pattern you are going to have, it should have the pattern repeated periodically, then it is multiple order sampling. Then multiple rate means different time period. If you are getting a sampling with a different time period, then it is multiple rate sampling. Multiple random means it is instance or random. It should be in the nature of random wise, then it is called it as an random sampling. Then another one is called a sampling theorem. That is very, very important in sampling process. That is nothing but whenever the sampling rate, that is your capital Fs, this is called sampling rate, which should be greater than or equal to 2 fm samples per second, then it is called it as a sampling theorem. This is very, very important. This is also called as a Shannon's sampling theorem. So the Fm, which is nothing but a continuous time signal with highest frequency bandwidth, that is sampled signal. The sampled signal and is a sampled rate. So whenever the sampled rate is greater than or equal to 2 fm samples per second, then it is called sampling theorem. This is also called as an Shannon's sampling theory. So for processing the sampled signals by digital, it should convert in binary code, and this conversion process is called quantization as well as coding. Okay, sampled signal by digital, that means it should convert into binary code, and it involves to process quantization as well as coding. And the process of converting discrete time continuous into discrete time discrete, then it is called quantization. So this is what happening in your sampled control system. So I think you have clear. So what are all the things we have discussed so far? What is sampled control system? Advantages of digital control, analog control. What is the block diagram of sampled control system? Then advantages of your digital as well as sampled data. Then what is sampling process? What is sampler? What is hold circuit? Then what is the meaning of quantization? What is the meaning of coding? Then different types of sampling. Then sampling theorem. Okay, thank you so much.